Hey there, Tom from Team Shenanigans, and wanted to talk about a new trebuchet we just put together. It was called a Tomfoolery. It's a quarter scale of the Shenanigans that we use at pumpkin chucking. We're going to use it for some testing, some ideas of things we want to change on Shenanigans, and see if it works out or not. And if something breaks, no big deal. We just lost a couple golf balls and some oak. So a couple people had asked about how we put it together, or dimensions and stuff like that. So I figured I'd just walk through it and kind of give you an idea of what's going on. We'll first start with the arm here in a second. So here's the arm. It's just a 1x of oak. I want to say it was probably a 1x6 that I ripped down because I used some other stuff. Just bought one big one altogether. And down here, as it goes down into the axle, I actually ended up with 3, and then I have some spacers to keep everything centered. And the same type of oak is used for these carriages. The wheels here are just casters from Lowe's as well. I want to say they're 1.5 or 1.5 yeah, 1.5 casters from Lowe's. What's nice is all 4 of these, I don't even think we need 4, because these guys right here weren't drilled perfectly, and even after probably 30 firings, these aren't even touching. So it's just riding on the front and back one. So if you're looking to save some money, you could probably shorten up these carriages and just have 2 wheels instead of 4. I plan on throwing a lot more weight on here, so that's why we ended up with 4. So you have just some bronze bushings in here, and then a washer is a spacer on one side because it wasn't perfectly even, so the other side doesn't have the washer. And then just some spacers in here, and then it's bolted up tight. It does have a bronze bushing on this guy as well, so it's just a piece of it's a 1/2 inch threaded rod. It goes all the way through, and as you can see, it's supported almost everywhere, so you're not going to bend that too much. Then on each one of these is a carriage bolt, and I drilled out these just a little bit to get it through here. These are all 1/4 inch bolts coming through, so it's a 1/4 inch carriage bolt, comes through, and then it's bolted tight to this side here as well. And then I use a lock washer on this side, or a lock nut, so that way it can still roll. It's not pushed up tight against there. Right now the sling is just some cheap cord until we get the exact length. In fact, I still want to use a little bit longer. And then I took some gloves, the leather gloves I had, and cut them out according to Ripcord has a post up on the hurl of how to build these guys. It's basically just a piece of leather, and then you cut some slits in it, some triangles out, and then put it all together and cinch it up, and this has worked perfectly. This is for golf ball size, and each diameter of projectile you want, you use different size leather. He has it all laid out there up on the hurl. I'll put a link up so you can see what's going on there. The track itself is just also from Lowe's. It's the extruded aluminum, and it's just secured to one end and then all the way down at the other, and the other end's the stops. The most controversial thing probably is this stop here. It stops the arm from swinging through on a big misfire and things like that. You can see it's kind of gotten dinged up a little bit already. I'm not much on it, but it keeps everything the same distance. On the real machine we don't have this because we have to have the cocking beam come through, but on this one, if I break the arm, we got plenty more, so we'll see what happens. The hardest part about the floating axle King Arthur is right here. This guy, for the centering, it's about 6 inches of space there. So any of your weights or anything you're going to use has to be less than that, or you end up with something like this, where if it's not perfectly level, you end up with a smack. So, a lot of different methods and people building things that didn't seem to work for how to get this thing to fire. We use, for the primary trigger, it's just this guy right here. When this is cocked, and I'll bring it up here in a second, just pull this out. You can see it's pretty nice and easy to pull out, and this allows the weights to start dropping. Then as we go on, I have this trigger down here. This is what I call the secondary trigger. The arm sits in here, and then this lays around and holds the arm in place. So the dimensions on this thing, the rails, these guys up here, are 4 foot long. And then down here, this guy, he's only 3 foot long, just because, you can make it that long if you wanted to. I made it the same size as the one that we already built, and we had extended the rails from last year or 2 years ago, so that's what we ended up with. Now width-wise, up top here, like I said, it was 6 inches, and outside dimensions are 9. And then down here on the base, outside to outside here is 19. And the total height from just floor up, we're looking at about 34 and a half, 34 and 3/4. And then each one of these little guys here is 8 inches. So this was all made the same as the original. And if you need to change anything, you can, obviously. Then for the arm length, this is where it gets a little bit weird. This one here, from the arm down to the pivot, is 31 and 3/4. And that's to the main axle. And then from the arm down to the counterweight is, what's that, almost 38 inches. So that distance between your main axle and your counterweight axle is your ratio. So ours is a little bit, I think it's almost 5 to 1. I'll have to check the math when I get back. But it started out 4 to 1 when Shenanigans was a 9-foot machine or something like that, and then it changed a little bit. So that's what we ended up with. So let me see if I can do this with one hand. I might not be able to. Cock this up and then show you what's going on. Probably the most important thing, and I don't know if a lot of people have it, is this bar right here. This bar, in a minute I'll show you, keeps the whole thing from rolling forward once it's cocked. So on the original, obviously you can't just do this because it's 1,300 pounds. But we'll lift this guy up. Excuse the camera. And then we'll open our gate up. A little bit tougher with one hand. And then this guy goes right in here. I'll close the gate up. This isn't perfect, but you can kind of get the idea. So I close the gate up. Put my foot on in a second. And then I use this out of the way. I use this guy right here. It's just a link that I have attached to a chain. I'll show you here. It just locks right in place. Let me open it up a little bit. This locks down on these two little pieces of angle. Okay, so that's it. Alright, so here it is in the cocked position. Up top here you can see what I have the counterweights resting on. This is a 1/4 inch angle that I welded together. Don't mind that weld, it's horrible. And I have some free weights that I get from Walmart. And you have to watch out. Get the ones that take the bolt with you. This is I think it's a 1/2 inch carriage bolt. You want them to fit through at least one of these holes. Now I can switch this out 2.5. I think I can get 5s on here. I haven't really tried yet. I'm not too worried about it. And then I have 4 of these on here. So that's only 10 pounds, but then this angle iron itself weighs, I think, about 5 pounds. So it does add a little bit of weight. Now on mine, I have this piece of steel, and then the wood's attached to it, and it really pivots on the steel and not the wood. And then here is my main trigger. So when this thing is loaded, this has, if you can see it here, it has a little bit of a tilt to it. You should be able to see it. So when I pull this out, the whole thing will tilt forward and start the whole process. Now the secret, and I don't think it's a secret for me, but I'm not trying to make it a secret, but is this guy here. No, be careful here. This is what I call a flapper. This was stolen. I think Chris Giroux from King Arthur has this type of thing, where as the weight falls down, this arm starts to move. Well, as this arm starts to move, it lifts this flapper up. And then that flapper is attached down here to the second trigger. So by changing the length of this chain, I can make this release early or late. And, oh, this thing's about ready to go. Put that back together there. There we go. So I can, once it releases, this arm is really pushing on this thing, and then when this pops off, this trap door of just 2 pieces of angle flies open and then lets the whole thing go. Now the key is this bar here. If this bar wasn't here, this thing is on a bit of an angle, as you can see. Let me back up, you can see it. That whole thing would roll forward on the carriage, and that bar keeps that from happening, because if it rolled forward, it would actually roll right out of the trigger and cause a misfire. So I call that the very ingenious name of the anti-roll forward bar. So that's kind of one of the things that people, I don't know if they mess up, but I don't see too much of those. So the bar, and if you put it up too high, it actually drags over the arm. So the lower you can have it, the better. But if you get it too low, it puts a lot of pressure on here, and you end up with a misfire. If it starts pushing real hard against that bar, it causes it to spring back when it lets go. So that, and then the secondary trigger, this guy right here, the secondary trigger, is kind of the two things that, I don't know, it seems to work pretty well for the machines that I've built. The last dimension is from here to the pivot. We're looking at about 24 inches from top to bottom. So it's a 24 inches of drop on those weights. So those weights will fall forward, kind of what I call thread the needle right on through there. And there's not a lot of clearance. Right now on this guy I have about 4 1/4 total when it's all said and done. And it has to thread through there, which is only 6. So if you have a lot of wobble in this thing, that's why you want to make sure it's perfectly level so it won't go down and fall and hit the rails, which we actually had on the big machine happen one time, and it put us out for the day. So here we are with 2 shots that I recorded a little bit later in the day. It's 120 frames per second on the Casio EX FH100, which I'm really kind of grown fond of. We're throwing about 500 feet. This angle is about 30 degrees trajectory, so it's not too bad. It's a good medium. Our sling length is about 100% of our arm length, which is a little bit surprising. But we're getting good distance, 150 feet per second, with only 15 pounds of counterweight. So it's working out pretty well for us, and we'll be starting some testing from here. If any questions, put it in the comments, and I'll be glad to answer them. Hopefully I haven't bored you too much. Thanks.